Hello. This is a recording to explain and help you understand my ENAE 380 final project that I titled Autonomous Tunnel Excavation, or 8 for short. This project is based in a video game known as Starbase, which you'll see on the screen right now. I'm flying to the moon to actually test this system, but this is footage from 2 weeks ago before I redesigned and learned a bit from my mistakes. Almost every clip in this video is sped up to 16 times speed. It's about 20 hours worth of screen capture recording that I fit into 20 minutes through careful cutting and speeding up. So it might seem a bit jerky at times, and other times it'll look really smooth, so just have to bear with that. But this should give you a good overview of what the game is like, as well as what this project covers. So at the moment, I am trying to land on the planet. And sometimes, I was a little crooked, I'll slow it down like this. And you'll hear my actual audio from the recording at that time.
But hey, I made it to the moon.
So like there, I said I made it to the moon. There's a couple of those. So at this point, this is 2 weeks ago, my initial design. I changed quite a few things after this, which I'll get into later. But it starts out by landing on the moon, spinning in place, and turning the lasers on. There isn't much autonomy at this point. I had not programmed much into it yet, just a simple script for controlling the laser's angle. And that didn't take too long either. Compared to some of the code, you'll see that literally takes hours for just a single chip. So here, initial test, I had this issue, or a couple issues, where the tunnel bore, the actual head of it, was drifting. Or like right here, for example, I discovered because of my laser configuration, I can't mine out the center of the hole. So that was one more thing I need to change. Otherwise it would make a very skinny pillar and a perfect bore hole that I could actually stand on and would eventually pierce the ship and break it. Here you see me trying to regain control of the ship manually. This is before I put code in. And I actually hit the ground at one point. That's what caused the whole thing to go off kilter. And the collision damage, removed some of the components, like the lasers that are actually doing the digging. Now, I do want to mention that this is on the public test build universe, or server of this game, meaning there is not really any consequences for me breaking things. This is not implemented in the live game yet, so that's why I had to use the server, because moon mining is a kind of new feature. It's up and coming. I started this project before it was even implemented, hoping it would be done in time, and it was, just on the test server. So here you see me making actually a pretty smooth hole, if I have to say, using a simple spin and just manual control of the lasers. This is not what is intended. I wanted the system to be autonomous, but I figured, hey, I might as well see if it can dig first before I see if it can control itself and dig. So, up till this point, there's been about 80 hours worth of design work into this ship. The Groundhog is quite an impressive feat in this game, at least by its standards. And it took a lot of time just to get to this point. This is the first time I've ever actually been to the moon in game, so testing was interesting. And I soon discovered that gravity would be my worst enemy, because it seems to be a little sticky. Oh, and here's a still image of the borehole that it just dug. Pretty smooth. So at one point, this is the gravity I was talking about. It'll slowly go down into a hole, and when it hits something, it'll bump itself up and kind of like pop up. It's an elastic collision, I'd say, for sure. So here, it just looks like it's going smooth, and that's how it was. And then it starts suddenly decrementing itself. Like gravity just flipped on for some reason, and you can see about, in-game it was about every second. It felt like it would just slowly go down bit by bit. And at one point, I was in this ship, I tried using the thrusters to reverse it manually, and gravity was just like the thrusters were not being able to fight it. Or it did eventually, but there was a delay, and a very noticeable like 5-second delay. So at that point, I would have already collided. I think I did. So now that all the testing's done and I thoroughly broke that ship, time to go back to the design of it. So here you see me adding on more coolant radiators because I discovered that I did not have enough coolant to run this ship at max capacity. So that's lesson learned just from a design standpoint, is you don't really know what you need till you go out and do it, and you run it for hours on end trying to figure it out. So you can see like manipulating individual objects in the game is a little bit, well, intensive, I'd say. And here you'll see me bolt things down in a second. Usually you don't have to manually bolt things. There's a auto bolt feature. But for something like this I actually had to. Because it did not want to play nice with the snap points in the game. But still though, it worked. And that's kind of why this design takes like 80 hours, because you're doing little tedious things like this over and over again. You can also see, maybe when I back out a bit, I added a roll cage to the front of this ship to try and set back the collision problems I was having. I learned that from my first test. So I did actually adapt this project and grow as time went on. It's a neat little roll cage. I made it stick out past all the lasers and every front-facing object at all points on the ship. Here you can see I'm trying to liberate some cables. There are very real design constraints, as I will talk about in the live portion of this from the actual recording in a second. But it's an annoying feature I have to deal with. This is an example of design constraints I have to work around. I have a pipe and duct limit, and I keep consistently reaching that, so I gotta cut back. And removing 6 thrusters when I have whatever 13 times 6 is 78. Not gonna hurt that much. Yeah. So like I said in the live version, I needed more cabling and piping. Because there are actual design constraints. It's not just build whatever you want. Like, there are limits. For this specific reason, all those new radiators I put on needed to be connected. So I had to remove a few connections because I kept riding the line of maxing that out. Here, this is when I'm first starting the test on my autonomy. At this point I was writing a script. I think I called it hover. But there's quite a few in there. Let's see. Yeah. This specific one is the hover script. So the goal of this script is if you're approaching a planet or approaching any solid object, you flip it on and it will maintain a reasonable distance from that object. Ideally the same distance that it started with when you turn it on. So this is practical for, let's say you're landing on a planet and you need to go use the bathroom real quick, or you know, your neighbors or your in my case roommates start knocking on my door and I need to take a pause, but I don't want to crash into the planet. In that case I would turn on the hover mode script. So that's what I was working on. I'll test it in a second in game and you'll hear my audio from that. But I was also adding in on the scripts on the right there, there's a all stop script is what I call it. It's like the emergency stop button. So if stuff breaks, you hit that. So I had to modify it and add in the hover mode so that would stop hovering. So here you see me testing. Those little green lasers are rangefinders on the front of the ship. They're what tell you your actual distance. Think of it like an ultrasonic sensor in the real world, or a light sensor, or laser pointer really. But that's a cool part about the design of this game, is you can actually take quote-unquote real-world information and manipulate it with your code. And here I'll explain. Wait, did that work? As it backed itself up, the engine shut off. Would you look at that? Oh, the reason it wasn't updating. Okay, so then If I hop into this beam and I start moving towards it rapidly, it's going to rapidly move away from me. Until start. Yep. And then it's going to decrement as this increases, and the thrusters. Yeah, look at that. It's working. Okay.
Glad you got our relation.
Well, the point of this system is to counteract gravity on the planet. So, like, if you start falling towards the planet at speed, it will turn this on. So, me approaching this laser is like me falling towards the planet, or this falling towards the planet. Yeah, that's the function of the script. You might have also heard someone else's voice in that. At the time of when I was doing this original recording, I was planning to do dynamics homework with a friend. He's in the other 380 section and did not help with this project at all. But he was watching a little bit as I was doing some design on it. He actually compared it to control systems because of how interconnected this is, and as you'll see in a sec with the programming of it all. But yeah, hover mode worked, so I moved on to the next project, which it's hard to see when it's moving this fast. I mean, 16 times speed will do that, I suppose. But at this point, I started working on the actual autonomy of the ship in moving forward and backward in a hull, as well as correcting for roll or pitch and yaw errors. So if you start turning while you're inside the hull, you want to be able to straighten back out so you don't collide with a wall. As well as you want to be able to move forward and backwards into the hole if you dig it out. So that's what this next section is about. And even at 16 times speed, this might look like a still image because I'm just looking at it, like figuring it out for that long. I was mentally like going through line by line, just comparing, like seeing, oh, this line goes to that line, and this line goes to that line. This is day 2 of me working on the scripts, and I kind of forgot how to do it from day 1 because it's a little bit complicated. It's not like a normal Python script per se. It's actually a C++ based language. But in a normal script, you have it run line by line. Well, here it's also running line by line, but there's as many pointers running as you see chips on the screen, and I think that is about 12 different simultaneous lines are running, different pieces of code, and they're all interacting with each other, or almost all of them are. So it gets complicated very quickly. And even at 16 times speed, again, this took hours and hours to get right of checking and testing and rewriting. You'll see me hop into, the designer has a test mode as well. That's what you saw when I was testing the hover mode. And you might have also been wondering, like, hey, wait, there's something there, like a beam or a girder or something. In that test mode, there's no collision. So I can technically just drive through the station if I wanted to. That is not the case in the actual public build test mode. When you go and buy the ship and fly it around, there is collision. And that is a very real issue that I have discovered hindered this project. But I'll get into that later. So right now, this is the actual in-game design test mode. I sit there for a second because it takes a little bit of time for your ship this big to initialize. There's hundreds of, actually, I think it's like 10,000 different components on the ship or more, or 20,000. It's a ridiculous amount. This is me debugging the ship. I have a little debugging corner in there where I can pull out any of these chips and look at it in real time as it's running. And that was just me watching it go line by line and seeing what was happening. At this very moment, though, I'm testing the pitch and yaw correction scripts. And I was not getting much success with them, if I'm being honest, because you have this issue with the rangefinders, where they always output the minimum value amongst all rangefinders that have the same name. So you name them and you call them. They're like calling a helper function, but in relation to real life. And when you do this, let's say you're in a hole, and if you start angling, then the side that is farther away, the opposite side is now closer to the wall. So I was having trouble actually picking up on when you're too close and how to correct for it. So I implemented basically a guess and check script where it would slowly move you and tilt you one way, and if you got closer to it, then it would reverse and then tilt you the other way. That took up a lot of time trying to figure that out, and it's not perfect. I didn't really have a good way to test it when I actually get to the moon in the last part of this video, because I never got deep enough for those rangefinders to even contact the ground. And you'll see why in a moment. But I also worked on the forward-backward section of just being able to dig in a hole autonomously. Moving forward like a tunnel bore, eating up the ground. Here I was messing with different laser scripts as well, in addition to this. Because the very first one, in the first part of the video, it set each laser to a specific angle, and as it would spin, those would increment and decrement a small amount to kind of jiggle in place. But they would stay in their pretty much their own angle measurements, so each laser was responsible for a single angle. At this point, I decided I wanted the lasers to all kind of go in and out together, like a fan, or like if something was breathing. They expand and contract at the same time. And I figured that would give me much smoother boreholes if it did it while it was spinning. And it would be easier to program a little bit. So I actually had to call on a helper function that I wrote for manually controlling the turret pitch, and it just autonomously manually pitches all the turrets to a specific angled degree measurement, and then waits like a couple seconds before it moves it to the next one. So it was kind of funny how I was overlapping different code, like the manual side with the not so manual side. Yeah, so this is one of the failure scripts. I had this problem where it wasn't letting me move in the way I wanted it to, so I was constantly like trying to figure out which script. There's 12 different chips to check, so I was pulling each one out and looking to see where it was getting hung up. And I eventually found it, changed it right there, I believe, and then put it back in its hole and grab the next one to test. Yeah, so it's a big ship. There's a lot of interconnected systems, and it's definitely, I'd say, worth the project itself. I spent over 100 hours doing everything in this, and I'm at the point this semester where I just run out of time. So, trying to get done as much as I can with it. And I feel like I did a pretty good job so far. Now you as a viewer, as a professor, or just as someone watching this on my channel, you might have no idea what is going on. And that's okay. All you gotta know is there's a lot of programming going into this ship, and a lot of careful design for its control and success. In a moment, I will call it quits on the actual design aspect, say, hey, enough is enough. If I had more time, I'd add in some nice cool lights, and I'd add in music, like I wanted to. A while back, some compatriots and I coded in bitwise music into this game using that code system, where it can actually read and run a chromatic octave worth of music. And we have some cool stuff. I have 1812 overcoded in, as well as like YMCA and some other fun songs. But yeah. So at this point, I'm doing my second approach onto the moon. I cut most of it out because we've already seen that at the beginning of the video, as well as the landing bit. I cut most of that too. Guess what just kicked in was my hover mode. I am 1 kilometer above the surface right now. Yeah, and that was slowed down and live again. I was 1 kilometer above the surface because the rangefinders have a 1 kilometer max limit. So when I turned it on, and as soon as it started getting within range, it hovered me above. So it worked. It was actually testing this stuff, and it worked. So I was pretty excited. Here I'm just trying to line up the bore head so that it's relatively flat with the ground. It's a pretty big ship relative to everything else. And I actually had this issue with my Autonomy where when I turned it on, it said, "Oh, you're too close. We should back up," which that's what it was supposed to do, but it was an unintended consequence of me setting it up, lining it up, and then it just reversing out of there. I thought it was funny though. Other little things, those lasers that you saw that were going straight horizontal with the ground earlier in the first video, I moved them down and facing around to the front. So now I can actually mine out the center. I don't have that issue where I have a skinny little spire sticking up in the middle anymore. And they still have the same freedom of range where they can spin around and go full horizontal. This I thought was a really cool clip right here, where it's just going to town, eating up the ground. And it looks like it's pretty stable, and then gravity kicks in, and then it messes it up. So it bumps right there, stuff's flying off, and the project, well, there's only so much you can do at that point. I do eventually retouch some of these things, but it got very quickly to a point of no easy return. And it takes about 45 minutes of in-game flight time to get out this far. At this point, I'm just done with this ship and its testing. So I never got deep enough into the hole to test the other scripts of it. So I tried blowing up the ship. Normally you can do that by pickaxing a fuel tank or a battery. But for some reason on the test mod, just wasn't happening. So that's my project. I hope you enjoyed it. Please read the write-up and give me a good grade, I hope. Thank you for being my teacher, and I hope you enjoyed this video. Goodbye.